I think we're going.
I think that works.
Yeah, the red light's
Yeah.
on.
Is it? Can you see it?
Yeah, I can see.
Okay.
Zoom in a bit.
All right. So it's having some display issues. Okay. So service discovery is a thing, and it's a pretty familiar thing, I guess. DNS. That's what you all know and love. When you go to google.com, you hit a DNS server, and it says, oh, google.com is 10.57.93. whatever. So service discovery has been with us for quite a while. But when you get into microservices, service discovery becomes a lot more important because, first of all, you've got a lot of services. If there's lots of small services and they're all running everywhere, you need to be able to catalog them, find them, etc. And also, they might be coming and going for various reasons. So basically, in terms of service discovery, how do you know where your services are running? So if I'm a client and I need to bind to a service, what host is it running on? What port is it running on? What are the characteristics of the service? So I might be looking for the customer details service, version 2.3, rather than version 2.2. So how do I find the right version that I'm looking for and bind to and use that service? So service discovery becomes fairly important. With microservices, large number of services, so there's a lot more of them defined. We don't want to have to configure them manually. That's a bit last century. We've got service coordination based on availability. So typically for scale out or highly available systems, we've got copies, redundant copies of that same service that are running in multiple locations. And they might be active-active, so we can hit whichever service we want, or we can do round-robin load balancing. They might be active-passive, so there's one leader service, and if it fails, then we fail over to another service that then becomes the leader. And we might also be using partitioning for read and write type workloads. So we might have one particular service for writing to, updating, and other multiple services for reading from. And things like the CQRS pattern, where you write to a particular interface and you read from a different interface, are examples of that sort of thing. So our service topology becomes a lot more complicated in the microservices environment. And it also becomes a lot more dynamic. So because services are coming and going, the idea with microservices is if you need to patch something and fix it, you do that over lunch and you deploy it out into production that afternoon and it's running. So the topology is changing all the time. And when we deploy a new version, the new patched version of that microservice, we want the clients to be able to discover and bind to that new patched version. And the other thing is we've often got ephemeral infrastructure. So things like EC2 in AWS, platforms as a service, Heroku, OpenShift, etc. Docker is a big thing at the moment. So the whole idea is that now the containers that our services are running in are a lot more ephemeral. They're coming and going, they're moving around within the network a lot more basically. So some familiar examples of service discovery. So DNS, internet scale service discovery, but it's not dynamic enough. So if my service fails and I update the DNS record to say, well, don't go to that server, go to the other server, it might take seconds or minutes for it to fail over, and in that time you've lost how many thousands of customers or futures trades or what have you. Unix, etc. services, that's where you've got your listings of I want to bind to HTTP, and that's on port 80 according to etc. services, so that's good. If you're running SOA infrastructure, you might be familiar with a service catalog. Maybe it's a UDDI thing. you go and find the service you want and you download the WSDL and you bind to that. In the olden days, people thought, well, UDDI would be a dynamic runtime thing where you would dynamically bind to the service you want, but I don't think anyone's really brave enough to do that yet. And then there's also things like distributed file systems, where if I've got a database that's in an active-passive configuration, and it's got a lock on the back-end file system, the primary is using the file system. If the primary fails, we want a way to fail over to the secondary. The secondary then needs to detect, hey, I'm the master now. I'm going to grab that file and I'm going to start using it in the full confidence that no one else has got that file. Okay? So you need very strong consistency requirements around that kind of failover. And so those kinds of things, the file locking, are known as lock servers, and they used to be very arcane things. So they used to come as part of the operating system. Various distributed file systems had them. Veritas, which was this clustering thing that's now owned by Symantec, that was a really nasty clustering system that no one could ever get to work, including the Veritas people. So they used to be arcane and difficult to use, and yeah, all of those kinds of things. But they're becoming a lot more popular and accessible now, which is a good thing for microservices. So the first real example of one of these lock servers out in the wild was when Google published a paper about their Chubby lock server. That was in 2006. There's a link here. Basically, the description of Chubby was that it allows clients to synchronize their activities and agree on the basic information about their environment. So who's using that file? What environment variables am I using? If I change an environment variable, how do I get that reliably distributed across all of the different clients there? Things like leader election. You go first. No, you go. No, I insist. You go first. So who's the leader? Who's the master database that I need to look for? Allowing leaders to discover the servers that they're working on. So if I've got a microservice that's got redundant copies, which one of them knows it's the leader and which ones are the followers, and how do they communicate with each other so that when the leader disappears, they can all agree on which follower now becomes the new leader. And to allow clients to then discover the new leader. So all of a sudden the leader goes away, all the clients go, oh, where do I go for the next leader? They know where to go. Chubby was also useful for metadata storage, so things that you might think are environment variables or might use environment variables for. Problem with environment variables is that they're all local to each machine. So I want a single repository that I can update a variable and have that replicated out and refreshed in each of the hosts. Chubby was never released outside Google, so we've never really used it in the wild, but it spawned some copycats, I guess. Copycats? I don't know. Zookeeper was the one that first really came out in the wild. It was developed by Yahoo, and they donated it to Apache. And it's become kind of the de facto lock server that's used in a lot of distributed systems. It uses this thing called the Paxos algorithm, which is the algorithm whereby all of the different services in Zookeeper can agree on who is the leader, who are the followers, and those kinds of things. Paxos was invented by this guy, Leslie Lamport, who won the Turing Medal in 2013 for his work on distributed systems. He was trained as a physicist, and he used relativity theory to understand how events and the order of events can be used to provide these strong levels of consistency. So, Zookeeper had to be developed by rocket scientists, basically. So Zookeeper is really great. It's out there, it's Apache, it's fairly mature, but it's pretty arcane and it's pretty difficult to use. Downloading it, running it is still a bit of a science project. More recently, there's been a couple of new kids come along, and a lot of them have been driven by the Raft protocol. So some guys from Stanford University, they went out and they looked at this Paxos algorithm, and they looked at all of the different implementations, and every single one was different. So no one could really agree. When it came to implementing Paxos, it's very arcane, very complex, and no two implementations look the same. And what they said was, well, let's come up with a new protocol that they called Raft, which is pretty close to Paxos. There's a couple of edge conditions that it possibly misses, but it's good enough. And more importantly, it's understandable, and most people can implement it. So Raft has been implemented. If you go to the Raft webpage, there's a big long list of implementations of Raft. And all of these guys are using the Raft protocol for their consensus algorithms. So Doozer came out in 2011. It was developed by a bunch of guys in Go. They called it a consistent distributed data store. It's not really doing anything now. If you go to the GitHub page, the last check-in was 2 years ago. The more active ones, etcd, I don't know how you say that, etcd, etcd. This is currently sponsored by CoreOS, and it's a very active, very popular distributed key value store that's being used in a lot of places. Consul is the one I'll be showing you a bit tonight, and so that's very active as well. That's being sponsored by HashiCorp, and that's pretty active as well. All open source, all easily clonable from GitHub, and all written in Go, funnily enough. Okay, so what's different about Consul? So the other things, Zookeeper or Chubby, Zookeeper, Doozd, etcd are all essentially data stores. They're small key value data stores that are reliably and consistently copied in every node. Okay, so if you take a copy of that data store into every node, and it has to sit in memory, obviously it's got to be a small database and it's got to be fairly performant. So we're not talking about, you don't put your customer database in any of these things. You put configuration and environment variables, basically. But effectively, these things are data stores, and if you want to use that, if you want to use the consistent information in the data stores and the events that you receive from changes in those data stores, to do things like service discovery and leader election, you've effectively got to implement that logic yourself. Okay? What Consul does is it builds on top of the data store. So it's got that consistent key value data store under the covers, but Consul also adds additional features and APIs for registering services, discovering services, etc., and also for monitoring. So a key thing with the service is you want to know when that service goes away. So you have to have some sort of monitoring system to allow you to do that. So Consul builds in that monitoring as well. It runs with agents. This is a bit of an architecture diagram. Consul is data center aware, so you can have multiple data centers running across Consul. You run a number of agents, and they can run either as clients or servers. The servers are the ones that cooperate in this Raft algorithm. So the servers are the ones that decide who's the leader and who are the followers. The clients are really there as just proxies. So the clients operate both as a local proxy, so I can send a Consul request to a client and it'll just forward it to a server. They also operate as monitoring nodes. So if I want to set up a monitor to ping my web server so that it's always sending back 200 OKs, I can run that in a client and it'll communicate in with the server system.
So is there a client per service?
Yeah, typically you'll have if I've got a data center with 100 nodes, 100 hosts, I'll have 100 clients running in there, and I'll have 3 or 5 servers. Okay. Typically, you'll run 3 to 5 servers. It has to be an odd number for the quorum protocol, and they'll go with the majority, basically. Okay. The other nice thing about Consul is it provides an HTTP and a DNS interface, so you can make a DNS call to it to get back a service location. Okay. Health checks. So there's two types of health checks: a script and an interval. So I can create a script, Python, Ruby, whatever. I can configure Consul to run that script periodically, and then depending on the results that come back, if it's a 0, a 1, or something else, it'll update the algorithm to reflect the status of that service. Okay. Or there's also a TTL service, which is like a dead man switch. That's where you rely on the service itself to communicate to Consul to say, hey, I'm here, hey, I'm here, hey, I'm here. So if it fails to report, then Consul will set it into a failed status. Okay. The HTTP API gives, so this is from the documentation, it gives you an idea as to what's available in Consul. So at the base level, there's the key value store. So I can put configuration variables into the key value store. When I change those variables, I can have events sending those changes out to the services, and they can reconfigure them themselves as you go. There's some add-ons. There's a thing called env Consul, which replicates the key value values into environment variables. So it's a bit like if you've ever used Heroku. In Heroku, when you've got a service running in Heroku, and if I go and I change the value of an environment variable, I can say, you are talking to that Mongo instance over there, I want you to switch to that other Mongo instance over there. I update the environment variable, that restarts, Heroku then restarts the service, and it'll change over. So env Consul does the same thing, except there I'm changing the value in Consul. Env Consul detects the change and then restarts the service so that it picks up the environment variable. There's agents, so you can control the agents, you can get them to join or leave the cluster, various things like that. There's the catalog, which manages the nodes and services. That's where you go to look up what are the services that I want, based on names or tags or what have you, whatever metadata, status, etc. The health checks is where you register health checks and manage the health checks. So if I were to create a new health check which will run periodically a script that will do the health check, that's where I do that through that API. Sessions and ACLs, so I won't go into that. Events, you can send events. So you can send any kind of user event with a payload, and Consul will simply distribute that event through the cluster. And you can have scripts which detect those events and respond to them to do things like restart servers or what have you. Okay. Tricky bit because I was...
There's a question over there.
So those events, are they guaranteed?
Yes, they are guaranteed, and they're guaranteed to be consistent in terms of the ordering. So, and also the combination of events and kind of status changes are guaranteed to be consistent across the cluster. So that's kind of the magic of these key value stores and the Consul, is that they guarantee consistency of those state changes and events. And yeah, the example they give in the documentation is if you've got an event that represents you've got events and actions, things like a server has failed, so you start a new server and then that server notifies that it's up. You want those three events or actions to absolutely be propagated through the cluster in that order, and that's what Consul does. Okay, so I was going to do a bit of a hands-on demo, but I don't. Let's see how we go. Okay. So I can run a Consul agent. Server, probably for the thing we're looking for, minus data dial. minus extract expect 1. Okay, so this is telling Consul. This is telling the Consul agent to start in server mode, so it's going to be part of the quorum protocol, and to expect only one node in there. So I'm only launching one node. If I'm launching 3 or 5, I'll put it in there, and it'll go around searching until it finds what it's expecting. What? No.
Did it scroll up a bit?
Yeah.
You can't see your screen.
I can't see my screen because I've got some crappy Linux video driver. It won't.
Doesn't actually tell you what's wrong.
Maybe you misspelled bootstrap.
Bootstrap space there.
You need to see bootstrap. Yeah, you need an extra name. Yeah.
Okay. All right. So there you go. So it started up. It said, "Oh, there's no cluster leader." Oh, hang on. I'm the cluster leader. So it does an election of 1, a bit like some recent political election. And so there we go. So my laptop is named Pugsley, and it's joined that, and we're all good. So so down here I can do things like Consul members, and it shows there's Pugsley and he's alive. I can do curl localhost 8500 / v1 / catalog. Am I spelling it right?
One more.
Catalog / node. Oh, very
I think you have to put in the protocol. Yeah.
that should be okay.
You can't see the headers.
Or maybe it's nodes. There we go. Okay, so there's my nodes, and I think I've got some services in there as well. No, I don't have any services in there.
So your service can either be configured by the API, but you can drop config files as well.
Yeah,
like
so-
conf.d sort of stuff.
Yeah, so when you start an agent, you can point to a config file, which is just a JSON file containing the services.
Yeah.
Also, through that HTTP interface, I can register new services in through that.
But there's also, you can do a conf.d so that any service that you can install can drop configuration into the console's directory as well, I believe, isn't it?
Maybe, I'm not sure. One other thing I have is a nice UI. So there's my my node, and that's the services, and there's my nodes in there, etc. So yeah, the only services I have at the moment is just the Consul service. So if I had a web service or a Redis service or a MySQL service registered in there, then they would show up. I'll show that in a sec. So just back to the... so there's some nice things that people have been doing around this. I'll come back to that. So this guy, Jeff Lindsay, I think his name is. The program on GitHub, etc. So he's been doing some interesting work with Consul and Docker. So Program Consul is a Consul agent that's in a Docker image that allows you to run Docker. Are you all familiar with Docker? Mm-hmm. So yeah, Docker's it's based around Linux agents, and it allows you to package up software and the environment for that software, and basically ship it around like a container. Hence the name Docker. So what Jeff's done is, Jeff Lindsay is his name. What Jeff has done is create a Docker image based on BusyBox Linux, which is a really tiny Linux instance, and it's got Consul running in it, so you can run a Consul network in your data center in Docker containers, and they can communicate with various services in there. And then this other project of his, Registrator, uses the Docker events so that if I package up my services, my microservices in Docker, and I start them and stop them in Docker, it uses the Docker event API to automatically register those services into Docker, into Consul. So just as an example of that, so if we go back into here, let me kill that guy, and I'll open up my cheat sheet. So I'll just run a quick cluster. So what I've done there is I've run Docker. I've run this Docker instance called Program Consul, and it runs in the background as a daemon. I've given it the name Node 1, and in that Consul command, I'm telling it to expect 3. So I'm going to create a cluster of 3 Consul nodes. Now, before I run the next Consul image, I need to know the IP address to bind to. So I do that through introspecting Docker. So the reason I need to do that is Docker is actually running its own network on my machine, just like a virtual network, a virtual machine network. So if I look at okay, so my Docker images are running on this network, 172.17.0.blah. So the next node I run, is that guy.
So minus H, right?
Minus H is the host name. So now if I do, I think if I do Consul members, I don't think this will work. Yeah, so all the Docker images are all talking on their own subnet amongst themselves. What I need is another agent that will bridge my laptop to that Docker network. And so the way I do that is by running this guy. So it's the same command effectively, but it's slightly different. Okay, so what we're doing here is we're starting another Docker image that contains, that's called Node 4, that contains Consul, that we're launching as an agent, so sorry, a client, it's not a server, so it doesn't participate in the protocol, but whenever we talk to that client, it'll forward all of our communications to the servers. And what we're doing is we're mapping the internal ports to my machine ports now. So now I can talk to port 8500, and that will be a bridge into the subnet that's running in Docker there. So now if I go back and say Consul members, so here's my nodes. I've got nodes 1, 2, 3, and 4. They're all alive. 4 is a client, 3 is servers. Okay. If I do something like Docker stop node 3, then it'll stop. And oh, it's not saying it's alive. There we go. So it says it's failed now. Now I can also open up my nice web page and do a refresh. So here I've got my nodes. So 1, 2, 3 is failed, and 4, and my services. So at the moment, the only services I've got is Consul, and I've got 2 healthy ones and 1 failed one. So let me just start that guy again. So now what I'll do is I'll start up this registrator, and this is where the magic starts to happen. Let's see. Okay, so registrator, all I'm doing is I'm running another Docker container. So now in my data center, here, I've got 5 hosts running. They're all running Consul, and one of them's running this guy that's registrator, who's just sitting there on the network, talking to the Docker network through the socket IO that Docker uses to communicate whenever Docker instances start and stop. And he's also talking to the Consul system to say, oh yeah, here's a new service that's just shown up. So when I start a Docker image that's got a service in it, registrator detects that Docker start and automatically registers that service in the Consul. So when I go and take something really vanilla off the shelf and just do Docker run honesty minus name redis.0 minus p Docker file / redis. So what I'm doing here is I'm going, I feel like running Redis. Redis is a column store, I think. It's a distributed database that's fairly popular. And it happens to have a Docker image up in the Docker repository. So when I say Docker run Redis, it'll go off to the internet, grab that image, download it onto my machine, and start it. So this is a pure vanilla Redis instance. It hasn't been configured to talk to Consul. It's never heard of Consul. Doesn't know what it is. I'm also saying the minus P says, just randomly map the port to any port. So normally you might say, well, Redis runs normally on port, I don't know, 6060 to make up the word. So I want to map 6060 to 6060 on my host so I know where to find it, okay? We don't need to do that with Consul and with Registrator, because what it will do is when it registers the service in the Consul, it'll also register the port that's been mapped to that service. So all of a sudden, all that port management spaghetti headache, I don't need to worry about that. So I start that up, and I forgot to delete the image from my old one. So I'll call this guy Redis1. So the reason I got that was I had an old Redis image from when I was practicing this afternoon.
So does this registration propagate to the DNS service underneath the covers for a SRV record?
Yes, yes. So we can do I'll show you an SRV lookup in a sec. So now if we come back to here. Okay, so you can see now I've got a bit more information in the services. So I've got some Consul services that are running, and I've got, magically, here's my Redis service that's been registered into the system. If I go look at that, then I can see it's running on node 4. It's running on node 4, that's the IP address. I don't see the port there. But if I go back to here and do a DNS lookup and say DNS at, so there's a dig at 127.0.0.1 minus port, look on port 8600. And now I'm looking for a service called redis.service.consul, and I want the SRV record. So then, now that tells me, yep, there's Redis running on that system, that's the IP address, and there's the port that it's been mapped to. So my client can now map to that port and start talking to Redis. Okay.
So is that because inside the Docker container for Redis, it has said this is a port that I want to be able to forward, or has it just detected that? Or has the registrator detected that out of the
Yeah, so the registrator, so when Docker starts up with that -P
yeah.
flag, it will randomly say, so when you create a Docker file,
Yeah.
you list which ports are exported.
Yeah, that's what I meant, yeah.
And so normally you'll do a -p, yeah, and you'll give the map in there. With just -P, you're saying, I don't care, just randomly assign a port. Registrator detects that configuration and uses that when it registers it into Consul. So hopefully you can see how using Consul, using Docker, is a way of being able to manage your microservices in a way that's a lot easier than doing it manually. Anyway, so that's pretty much all I had to talk about Consul today. Hopefully that's sparked your interest. Go and play.
Cool.
Any questions?
Have you used this in production yet?
I haven't, no. I'm just playing with this. But there are people who are using it in production. So HashiCorp are using Consul. They run data centers all over the place. In fact, let's see, they've got a demo where you can connect to a bunch of, so New York City, that sounds like an important data center. So you can look in there. Oh, it doesn't really have much, does it? Yeah, there's some Redis. So this isn't a real production data center, obviously. But yeah, so you can see what it might look like in the bigger data center. So there are people using certainly Consul in data centers in production. I suppose there's people using Docker as well, etc.
So when you're writing a client that uses the DNS discovery to find out where it needs to go and talk to something else, it pulls down the SRV records. Are there many libraries at the moment that sort of like implement that? You know, because you can also use the weighting and the priority and all that sort of stuff.
Yes.
Do you know of any libraries at the moment that'll do that parsing and selection for you and the retries and stuff?
So you can do, when you want to pass those arguments around, I want to search based on attributes and status and all that sort of stuff. I think the DNS lookup is fairly limited.
Yeah.
So with DNS you can do tag.name.service.console. The HTTP interface is a lot richer. And then there's also some Go clients. So there's various clients in various languages that you can use as well. But yeah, the HTTP interface exposes all of that to you.
So have you, I don't know, you're obviously playing around with it yourself. So the cool thing is, well, it's the DNS thing, right? It's just automagical and it just works for you. But it obviously doesn't do the load balancing across the, you know, you've got end services and end priorities and, you know, these are the fallbacks. You still have to implement your client to actually do that sort of work. But would you suggest using the API for that part of it rather than using the SRV? Because what's the use of the SRV then just other than, hey, that's pretty.
Yeah, so that's getting to the bleeding edge of my experimentation here. Really, the way you would use it is by looking at the events. So when a new leader gets elected, for example, it would trigger out an event. You'd listen to that event. The client would say, I need to now change to this new leader, etc. So there's ways to build in those event listeners and that sort of stuff into a client.
So I guess it's when you're writing the client, you have to be Consul aware. It's not a matter of just, hey, use DNS. I mean, I guess that was sort of the intention behind the fact that it's just DNS, is that you can just go, you know, write my .NET service that's, you know, go to that URL and it'll give me back an address and I'll go, yay. I don't have to worry about any of the other stuff except for the port stuff, obviously.
Yeah.
And so your clients have to become Consul aware. To a certain degree, I mean, this.
Yeah, I think to a certain degree, they will.
Yeah.
It depends on how sophisticated you want your infrastructure to be. If you're just happy with, I've lost the connection, let me do a DNS lookup.
Yeah.
I think the nice thing about the Consul DNS interface is it doesn't have a time to live of
Yeah.
10 minutes or something. So
It's
it'll
pretty
be a lot
instant.
more responsive.
Yeah, absolutely.
Okay, all right, thanks for your time.
Thanks.
So we'll have a break, help yourself to some more pizza and beer, and then we'll hand over to Sean while he sets up.